My AI tells me that by the end of 2023, a player-like device, for example, is going to have a big performance drop, and on the flip side, a lot of FaZe clan players are going to have a big resurgence in form, especially Kerrigan.
Okay, that was quite a nice one from Rain, and Kerrigan! Oh, Kerrigan!
And based on this, I have to predict FaZe clan being very dominant in the early phases of CS2.
Still not planting, not in a hurry. Oh, and it's costing them! The flash, the ping! Oh! Hands together! You're champions! From IEM Sydney 2023!
Cuckoo. So a couple of months ago, I was riding a train with a friend and we had that one conversation about AI being dangerous. But throughout the conversation, I could see that my friend's understanding of AI was based on what he thought AI was and not what it actually is. I noticed people tend to overly romanticize AI and misunderstand it. In reality, AI is just a bunch of algorithms and techniques that allow a computer to simulate intelligent behaviors like finding its way through maze or making intelligent and intuitive predictions based on some data. When you take a closer look at these algorithms, you see they can reach high levels of complexity because of all the mathematics involved, but you kinda struggle to see where the intelligent part comes from.
What number comes between 2 and 4?
25.
Wait a minute,
Hold
Beetlejuice.
it.
I want you to think about
Think
it.
about it. Don't blurt out your answer. What number comes between 2 and 4?
2 and 4. 36.
So I can hear some of you coming at me and asking, well, what do you mean by predicting the future? And you would be very correct to ask. Phrased that way, the definition is ambiguous, and it certainly doesn't work like predicting the future in a crystal ball. The reality is probably more in line with predicting the evolution of a quantity or a value. So now that we agree on this, I want to leverage this opportunity to show you how some very smart people came up with methods that involve AI in order to do it. Let's go. Our story starts in 1801 with the discovery of a celestial object. In Italy, an astronomer observes a dwarf planet in the solar system for the first time. He names it Ceres, after the Roman goddess of agriculture, and starts making observations. However, he very quickly runs into a problem. Ceres' glow starts becoming less and less visible as its orbit comes closer to the sun. Eventually, the sun simply outshines Ceres and Giuseppe loses track of the dwarf planet. All his attempts to relocate it are not successful. Then the same year, German mathematician Gauss managed to solve the problem in the following way. Let's take a linear function. When you were learning how to work with functions in school, you must have learned that a function has an input and that based on the value of this input, the function's output is going to be different. Traditionally, this is what you call a variable. And beside the variable are other terms in the function that are called parameters. These are called parameters because they're static and they define the behavior of the function. Then sometime later, once you became familiar with calculus, you started working on optimization problems like, Mr. Putis has 50 meters of wooden fences. How should he arrange his wooden fences in a rectangular shape to maximize the area it covers? In which case, you calculate the derivative and solve for x when it's 0. But Gauss had a different idea. What if, instead of solving for the variable, we solve for the parameters? Let's say you have a certain amount of data points and you want to draw a line that on average comes as close as possible to all these data points. Well, how do you find the parameters of the said line? Gauss expressed this average distance of the line to all the data points by a sum of squares, and then simply did what we discussed before. He found the values of the parameters that minimize this function, and called the method least squares. By doing this, he could, quote, predict the future and have a very good idea of where Ceres was going to appear back again in the sky. Let's say that now we don't want to predict the future position of series anymore, but something more complicated, like values of shares in the stock market. So, what do we do? To answer that question, I want to show you by looking at my favorite game of all time.
And a straight flash high in the sky, they won't be able to dodge, means he can go back for more, and he certainly will. Finds a second and a third. Snacks on fire, what a shot!
Fundamentally, Counter-Strike is a 5 versus 5 tactical shooter. On one side, a team of terrorists must plant a bomb on one of 2 bomb sites, and a team of counter-terrorists must defuse the bomb. Either team can win the round by eliminating the other. So here is my question for you. Can you build an AI model that will predict how well a player will perform in 1 month, 2 months, 3 months? Before we go any further, I'm gonna have to introduce you to the idea of inference. It comes from the verb to infer, and if I read the definition from the Cambridge Dictionary, it mentions to form an opinion or guess that something is true because of the information that you have. Let's take a tennis ball and nudge it slightly forward on a flat surface. You probably don't need to be a genius at mathematics to figure out that the ball is going to move in a straight trajectory. You can also make a very good guess of where the ball is going to be after 1 or 2 seconds of moving forward. You know what is going to happen, but not because you have put any analytical skills to work. You know because you used your intuition. You inferred something from the context. The key to understanding inference is in patterns. Because you have seen the same thing happen over and over and over again, you are sure that in the same conditions it's going to happen again. If we go back to the example of the tennis ball, if you nudge it forward, it's not going to fly up into space for no reason. Well, machine learning models work in the same way. You give them data that they train on, and by doing so they can learn the patterns in the data. Another way to understand this would be to think of a fortune teller by looking at your hands, your face, your hair, how your hair is made, how well you dress, how much money you seem to have. They can predict things that are very likely to happen based on the context you present them. Here is a very simple example for your understanding. Now let's circle back to the title of the video and make a quick summary of all of this. From looking at the example of series, how can we make an AI that will infer the future performance of a Counter-Strike player? So basically we're going to do the exact same thing Gauss did to predict the future position of series, a couple of differences aside. The first one is our data looks much more complicated. Basically there is no obvious pattern to work with in here, which leads to the second main difference. The model we're going to use is much more complex, which in turn leads to the third difference. Because the model is more complex, we cannot simply find the optimal parameters that fit the problem. So step by step, we're going to progressively work our way to these parameters by using a method called gradient descent. Now, let's go and make this work. So now our model is done training and it works really well, but we have a problem. So basically last time I ran my scrapping algorithm to gather the data was in early June. So my idea was to first train my model on the data that goes up to early June, make a forecast for the next 4 to 5 months, and then 4 to 5 months later re-download the data and make a comparison between what my model predicted and what actually happened. But as I'm recording this on December 2nd, when you go on HLTV now, since they remade the website for the release of CS2, a lot of performance graphs don't show anymore. So I basically cannot download the data anymore. This is a big problem. So because of this, the visuals of the comparison will not be very appealing because I'm gonna have to use screenshots directly from HLTV and compare them to my generated curves, but hopefully it will be okay. If you remember at the beginning of the video, I was talking about FaZe Clan being very dominant in the early phases of CS2. This is an audio I recorded back in August when I was done training my model and I saw the first results. And based on this, I predicted that FaZe Clan was going to have a huge resurgence in form. Now we are in December, reality happened and we can finally make a comparison, so let's go for it. If you pay attention, you're going to see that my graphs look smoother than what you can find on HLTV, and this is normal. This is because when processing my data, I actually denoised it. I removed all the unpredictable day-to-day variations to only keep the general trend. If we take a look at the predictions of our model, I think it did a really good job for 4 out of the 5 FaZe clan players. I'm gonna put the predictions and the reality side by side so you can see for yourself. I would argue that the predictions for Kerrigan, Rain, Brokey, and Twists are really accurate and things turned out the way it was predicted. The only player in my model messed up with was Rops. If you look at my forecast, Rops was supposed to have a big performance drop by the end of the year, and the exact opposite happened actually. Rops has been absolutely phenomenal so far in CS2 and my model was wrong. And he is now one of the best players in the world, so I guess mistakes happen. So that's it for this video. I hope you found it interesting and you learned something useful. Now I'm gonna leave you with some other forecasts my AI made for a lot of different players, see how they compare to reality. That way you can make up your own opinion of whether like this is legit and actually works or not. So I'll let you have a look at it and I'll wish you all a good night. See you.